So to determine whether the following function is a polynomial function, if the function is a polynomial function, state its degree. If it's not, tell why not. So again, we will write the polynomial in standard form if it is, and then identify the leading term and the constant. Some things to also pick up on is what does a negative exponent do? So if I have 2 to the negative 1, that really means the same thing as take the reciprocal. That's 1 over 2. So by definition, if I have x to the negative 1, that's the same thing as 1 over x. So if x is in the denominator, that means it actually has a negative exponent. Another thing we pick up on is if I give you, say, 4 to the 1/2, that's the same thing as the square root of 4. That power of 1/2, that denominator tells me what root to do. So that's actually a radical problem square root. So if I have x to the 1/2, that means the same thing as the square root of x. So if we have negative exponents or fractional exponents, negative exponents represent reciprocals, and fractional exponents represent these radicals, things like that. So remember, to be a polynomial function, the exponents have to be whole numbers. So we're talking about 0, 1, 2, 3, so forth and so on. So notice this x to the 7th, that actually means the same thing as 2 minus x to the negative 7. So notice that actually is a negative exponent. For it to be a polynomial function, the exponent cannot be negative. So it's not a polynomial function because the x is actually raised to the negative 7th power, which is not a non-negative number. It's actually a negative number. So this would be the actual answer to this question, is because since 7 is in the denominator, that would be flipped back up as a negative exponent, and negative exponents represent, we would not call that a polynomial function because of that.